Hello everyone, myself Abhilash Reddy and my teammate Shrikar. Now we are going to explain about the topic virtual machine environments. These are the table of contents we will explain now. So before talking about virtual machines, let's discuss about the virtualization. Firstly, due to the limitations of x86-bit servers, many IT organizations must deploy multiple servers, each operating at a fraction of their capacity. So, in order to keep pace with high storage and processing demands in today's, there is a drawback of huge inefficiency and excessive operating costs. So, because of these issues, we are entering into a virtualization. Virtualization relies on software to simulate hardware functionality and create a virtual computer system. This enables IT organizations to run more than one virtual system and multiple operating systems and also applications on a single server. The resulting benefits includes economies of scale and greater efficiency. So now there are four different types of virtualization. Firstly, server virtualization, network virtualization, and desktop virtualization. So now let's discuss about the connection of virtualization with the virtual machines. As I said before, virtualization uses software to create an abstraction layer over the physical hardware. In doing so, it creates a virtual compute system known as virtual machines. This will allow organizations to run multiple virtual computers, operating systems, and applications on a single physical server. Now let's go into the more details about what is virtual machines and what are its key properties and its uses. Now let's talk about the key properties of virtual machines. The first property is partitioning. With this partitioning property, we are able to run multiple operating systems on one physical machine. And also we can divide the resources of system between virtual machines. The second property is isolation. This property provides fault and security isolation at the hardware level. And we can achieve the preserved performance with advanced resource controls. The next property is encapsulation. This property saves the entire state of your virtual machine to files, and it moves and copy virtual machines as easily as moving and copying files. The next property is hardware independence. The provision or migrate any virtual machine to any physical server is the property of is one of the property of virtual machine. And I think I'm pretty much covered the introduction part here. So let's move to the next slide. Now let us talk about the benefits of a virtual machine. The first benefit of virtual machine is operational flexibility. We will have a flexibility of operating separate instances of multiple operating system types such as Windows, Mac, and Linux. The big draw of virtualization is to operate multiple displays and event systems such as Linux and Windows, for example, from the same console. This allows users to toggle among applications regardless of their OS. VMs, virtual machines, simulate the experience of using multiple computers at the same time for complex servers with multi-system needs. Moreover, those systems remain entirely separate from each other, which adds a layer of security to your operations. The second benefit of virtual machine is reducing overhead. Overhead costs do not just happen when you purchase new hardware. They continue throughout the life of your workstation. The continuous expenses of hardware maintenance, power, and licensing can take a toll on your business. Of course, VMware still requires power usage and software licensing, but resource consumption with VMware can be remarkably lower than resource consumption with multiple hardware-based systems. Virtualization ensures there is no less to constantly main and replace hardware. We can run multiple virtual machines on the same underlying software. The next benefit is centralization. Virtual machines combine a number of things into a single more effective systems to simplify management. Centralized management of diverse operating units allows you to increase efficiency and ultimately to increase your output. Virtual machines are useful because they offer an opportunity to consolidate your IT management into one console. This can be much more efficient than managing multiple physical devices. VMware and VM management software can be managed through a single dashboard with all of your applications. Many businesses find there is no easier way to keep track of so many apps, systems, and operating units. Coming to the next benefit, that is scalability. A growing business requires constant investment in new IT tools. Consequently, the space and maintenance cost of adding hardware must factor into your plan. Because virtual machines are highly scalable, your plan can be much easier with a virtualized environment. Because VMware enables you to add and remove apps with no physical overhead. An expanding virtual infrastructure doesn't require complex budgets for hardware resources or added floor space. The last benefit of virtual machine is disaster recovery. We don't know what's gonna happen, so we need to be more careful in storing the data. Though sometimes we may lose data, but we need to be able to recover it. VMware can be a highly effective solution for disaster recovery because virtual machines make regular copies of their operations history, copies that you can retrace and revisit as necessary. There is little risk for data loss in case of an unexpected hardware failure. Additionally, because there is negligible hardware overhead in your virtual environment, your server will pose a lower risk of system failure to begin with. Here we can easily recover the lost data as virtual machine restores data and system states from virtual machine instances. There is also one more benefit of virtual machine is it offers instruction set architecture that differs from real computers. Not only the benefits, but there are also a few disadvantages with the virtual machines. The disadvantages, the first one is when multiple virtual machines are simultaneously running on a host computer, each virtual machine may introduce an unstable performance. And virtual machine is not that efficient as a real one when accessing the hardware. Why should we use virtual machine? There are plenty of reasons why virtual machines have become a centerpiece of efficient IT systems across the business world. Virtual machines allow multi-system applications to run at the same time in the same place without overhead. Here are some of the main reasons why business large and small use small use virtualization as an IT solution. The use of virtual machines is to support separate cached operating systems that are popular in regard to embedded systems. A typical use would be to run a real-time operating system simultaneously with a preferred complex operating system, such as Linux or Windows. Another use would be for novel and unproven software still in the development stage, so it runs inside a sandbox. Virtual machines have other advantages for operating system development and may include improved debugging access and faster reboots. From now, next topics will be covered by Shrikar.
Hello everyone, this is Shrikar. Coming to my topic about virtual machine environment pattern. Coming to intent, provide units of execution called virtual machines which have access to virtualized hardware like processor, memory, and networks. A virtual machine environment creates and manages virtual machines according to the user request or system needs. For example, a new company wants to develop application programs that need to run in Linux or Unix, supported by different hardware platforms. Doing this development requires access to a variety of hardware, all of them running Linux or Unix. This is expensive and requires additional time and expertise to set up these processing environments. We just don't have enough money to do this work and we cannot develop the intended applications. Coming to context, many companies and individuals need access to inexpensive processing power. Many companies develop software intended to run in multiple hardware platforms and their software needs to be developed and tested in platforms. So coming into the problem, how do we provide inexpensive computing power to many users? That's a question. So the real process can be purchased and used to host applications. However, this is expensive and most of the resources they provide will most likely to go underutilized. But the possible solution is constrained by the following forces like access to hardware features. Some applications may need access to a specific set of hardware features to support their execution, like flexibility, isolation, modularity, usability, portability, extensibility, elasticity, management, and monitoring. So now I'm going to explain about flexibility. We would like to run different type of operating systems or system software in each execution instance. Coming to isolation, there should be no way for a user in an execution environment to get access to the data or functions of another environment, either by error or intentionally. When an OS crashes or it penetrated by a hacker, the effects of this situation should not propagate to other environments in the same hardware. Isolation is an important requisite for security and reliability. Coming to modularity, execution instances should have well-defined interface to the software that will execute on them. This can improve interoperability. Usability. Configuring an execution environment should be simple. Coming to portability, we want execution instance to be portable across hardware processors. That is, they should be able to move or copy it from one processor to another processor without special handling. Coming to elasticity, it should be possible to dynamically increase or reduce the resources needed by an execution instance. This is a useful feature for applications that need to handle variable loads. Management. It should be possible to manage execution environment to control the number of virtual machines, migrations of virtual machine across processors for reliability, and load balancing for optimal use of resources and monitoring. It should be possible to monitor the state of activities of virtual machines. This could have value to assure SLAs. Now, next topic is about the social solution for virtual machine environment. Providing a platform called Virtual Machine Environment, called VMEs, to create and manage execution instances like processors, where application developers can think they are interacting with the real hardware. The virtualized processor, a virtual machine, will have all the features of a hardware processor, except the same speed. Virtual machines are useful to provide inexpensive computing power and variety of instruction sets. Virtual machine environment provide a platform for creation, management, security, load balancing, monitoring, etc. of virtual machines. In this case, the software or even the hardware can be chosen as a support the application and optimize or improve a non-functional requirement. A variety of software, example database, analyzing packages, can be obtained from the service provider and loaded into virtual machine using a menu-like approaches. Now coming to the topic called dynamics in VM. Use cases for VMS includes creation and deletion of virtual machines, defining access control for virtual machines, adding resources to VM, VM migration, VM replication, load balancing, monitor VMs, and others. Use cases like creation of virtual machines by a cloud system requires users of infrastructure as service. Functions. A user needs an account and needs a specific location. The VM is assigned to a code. The final objective for a user is to build a VM path is set of selected software units, typically an operating system called DBMS, develop tools, etc. The size of memory location and other features can also selected as well as access control routes. In the above figure of VM creation in dynamic section, it shows the sequence diagram steps performed when user creates a VM. For the creation of a virtual machine, a user can create a virtual machine image which is required a set of resources or select an existing VMI from VMI repository. We assume here that the user selects an already existing VMI from the repository. First, a user requests virtual machine environment for creating a virtual machine by providing a list of resources. The VM selects a VMI for the repository based on the user requirements. Third, the VMI repository provides the requested image. 4. The VMI sends request to virtual machine along with VMI and list of resources to create a VM. The VMM initiates the VMI to create a VM with the requested resources. The VMM assigns required hardware resources to VM. The VM is assigned to the consumer and acknowledgement is sent by VME to them. The VM has been created. Now coming into the next slide called implementation. Now coming into the implementation part, VMs are created by virtual machine monitor. VMs can run on a real hardware like bare metal VMM or in a host operating systems like type 1 and 2 hypervisors respectively. In the latter case, input and output drivers of the guest operating system run in the host operating system. This reduces memory needs and improves performance, but it makes the virtual environment more complex, which makes it more vulnerable to attacks. VMs can be created from virtual machine images or in ad hoc way by the user. VMIs are kept in a VMI repository. VMIs load VMS with different amounts of storage, specific software or other features. Communication between VMs and US or external systems can be done using real or virtual networks. Virtual networks can use physical devices or virtualized functions. There are several types of virtualization which can have an influence on the speed and security of corresponding VMs. There are 4 types of virtualizations. One is full or native virtualization. The second, virtualization, third, operating system virtualization, and fourth, library level virtualization. So coming to full or native virtualization. The guest operating system is presented with a full hardware instruction set and executes all instructions either directly or through the hypervisor. Some instructions do not trap and need extra binary code to be executed. This problem can be solved using hardware-assisted virtualization, where all privileged instructions trap to the hypervisor. This is the simplest approach as there is no need to modify the guest OS. Now coming to para-virtualization. This approach presents a software interface to VMs intended to reduce the portion of the guest execution time spent performing operations which are substantially more difficult to run in virtual environment compared to a non-virtualized environment. It requires specifically tailored guest operating system running the VMs. In class diagram for this type of virtual machines, guest OS would provide a customized instruction set. Now coming to the part of operating system virtualization, allows the users of a computer to be partitioned via kernel support for a multiple isolated user space instances, which are usually called containers and may look and feel like real machines to the end users. In case of OS virtualization, the virtualization environment would be simpler than VME. The components like guest OS and virtual machine would no longer be required. Software containers are examples of OS virtualization. It can be seen that the containers operate with a lesser number of layers and therefore offer a lightweight execution environment as compared to virtual machines. However, since containers share the host OS, the resulting solution offers less flexibility. We cannot run together applications that need different operating systems. Of course, we can mix together in a cloud system, VMs and container. Now coming to the part of library level virtualization. Produces a different virtual environment working above the OS layer by implementing a specialized application, binary or programming interface. Unikernels are examples of library level virtualization. Here the application code and your runtime environment specialized kernel which is run directly on the top hypervisor. Now coming to the non-users. The VirtualBox is a free and open source VMM from Oracle for x86 hardware VirtualBox 2016. And kernel-based virtual machine offers full virtualization for Linux on x86 systems. And the third, IBM VM 370. This was the first VMOS it provided virtual machines for an IBM 370 mainframe. Now coming to the consequences. The virtual machine environment pattern has the following advantage, like access to the hardware features. So here you can see different type of consequences that we can see in virtual machines. So there are like 9 types, like flexibility, isolation, modularity, usability, portability, extensibility, elasticity, management, and monitoring. So coming to flexibility, we can run different types of monitoring systems or system software in each VM. So there are like 9 different types. So now coming to the conclusion part of virtual machines. Virtualization has long established itself an enabler of many technologies, including to the cloud and IoT. Virtual machine environment enables the creation and management of virtual execution environments. It provides a way to virtualize cloud hardware and infrastructure as a service. This pattern is a part of ongoing work on cloud ecosystem, which aims to developing a holistic and unified view of cloud to its users, designers, developers, and researchers, suitable to analyze aspects such as reliability and security. Many components of the system have already been modeled. Some still have been defined as patterns. As the cloud system computing evolves, new components will be added at the cloud ecosystem. Model will also require updates and addition to the reflect these changes. We are now working on architectural model of container clusters. So coming to the references, there are like 4 different types of references. So here are some of the references regarding the topic of virtual machines. And thank you for the listening.